Hi everyone, and welcome back to Fundamentals of Engineering with Farhad. Soil mechanics stress in foundation. So we have a foundation and a column at point A which applies a force of P at this point. So we have a plan of a foundation with an axial force of P applies at the centricity of X from X and Y axis. We want to know what is the maximum eccentricity in which no point in the foundation is under tensile stress. So let's approach our problem. So by transferring our force from point A to center of our foundation, we will create some moments. So for example, by transferring the force to the C, and applying the opposite force at the location of force, these two forces cancel out each other and we have the force at the location of C. But there is a moment which develops about the axis y, so that's my, and that's nothing but the force times the distance, which is x. And then likewise, if we consider it in the other direction, so it also creates a moment about x direction, and that's nothing but p times x, that's m sub x. So we have like my and mx, both of them are equal to p times x due to the same eccentricity. And as you can see, the effect of these two moments are both tensile at the location D. So that's the critical point and that's the maximum tensile stress in our foundation under this point. So if this point is safe, our design is safe. So let's see, P over A, force over the area of foundation, minus mx times c over moment of inertia, minus my times c over moment of inertia if it's bigger than 0. So no point in our foundation is under tensile force. So for calculating the distance for mx, you can easily see the point D has a distance of b over 2 from x-axis. Likewise for my, you can easily see we have like the distance of point D for my is also b over 2, this distance. So as soon as we have replace the distance for both moment in the main equation, and I is 112 base cube height, and because our foundation is like a square, so this is b, that's 112 b to the fourth, and the moment itself is simply p times x, p over area minus px b over 2 over 112 b to the fourth minus the same term should be greater or equal than 0. So area is b squared, and if you replace that, b squared, p over b squared should be bigger or equal than 2y of px times 6 over b cubed. And if you do the math, it just says x, or eccentricity, should be at least equal to a b over 12, or the dimension of our foundation over 12, to be safe in our design. So the answer for avoiding the foundation, any point under our foundation to be in tensile stress, is choice number C and B over 12. Thank you. We'll solve more problems in foundation.